Hello everybody. Today let's look at the application of Newton's law in our physical examples. So here we have seen that we have got an arrangement where m1 and m2 are the two masses which are attached with the string. Now when these two masses are attached with the string, what they will have is that they will have a tension between them. And we know that tension is like a force which will always act away from the body. So the direction of the tension is for M2 block it is going to be upward, and for M1 it is going to be this way. Now if you see that, if suppose the system has got some oscillation over here, and this oscillation is nothing but say it is A over here. Okay, now if we try to solve this, let's first try to draw the free body diagram. If I see this is block M1 with mass M1, this is having a tension T over here and it is having acceleration A. If for a moment we neglect the frictional force F, then what we can say for this is that T is equal to M1A. Now for the second body, if we try to draw the free body diagram, how is it going to look like? Say this is the second body and it will have a tension force acting away from it. It has got an acceleration on the downward direction as the total system has got an acceleration of A, and since this is a rigid string, so that way, okay, so this is this, and then what you can say is there is a gravitational force acting over here. Now in this situation, if I have to write the force equation, then what I am going to say is I will say that this block which has got, you can say, mass of m2, then I can say m2 into A. This is equal to, basically it is m2g minus t. Alright, so we have got, this is our first equation and this has got the second equation. Now let's try to find out what is the oscillation of the system. Now in this, if I just go on substituting this over here, I will get m2a is equal to m2g minus m1a. That is nothing but, you can say, m1 plus m2a is equal to m2g. So what we got is, we got the equation for oscillation, that is m2 upon m1 plus m2 into g. So this is the oscillation of, you can say, the system, that mass m1 will be also having the same oscillation as mass m2. So this is about oscillation. Let's try to find out then the tension in the string. Now the tension in the string is, I can simply say m1 into A, that is m1 m2 into g. It will become an m1 plus m2. Alright, so this is how we found the tension in the string, and this is how we found the oscillation of the system. Now let's move to our second example, which is over here. Now in this example, let's say that this has got mass m1 and this is mass m2, and say this angle is theta. Now here, for a moment, let's say that there is a tension T over here and the same tension is T over here, over the same rope, since they are connected with the same rope. Now if I just try to see that what is happening over here is that this system is moving with oscillation downwards with A, and G is obviously acting over here, and this system will be moving with oscillation A. And if I try to see the free body diagram over here for m1, what I can say is, if I draw this, so this is m1 into g acting downward, and this angle is theta basically. So this component, or you can say this parallel component, it is going to be m1g sine theta. Okay, and this is, you can say, m1g cos theta, right? Okay, so here for this block m1, if I went on, if I go on writing the, you can say, the equation, then you can say it is going to be you can say t minus m1g sine theta is equal to m1a. This is our first equation that is coming from the first block. Now let's look for the second block, what we can say. For second block, I can say that it is moving with oscillation this, so you can say that m2g minus t is equal to m2a. That what it is. Now since we have to find the oscillation and the tension, what we'll do, we'll try to add the two equations to solve them. And what if I add it up, I can say m2g minus m1 sine theta into g, that what it is, and this will become m1 plus m2 into a, that what it is. Now, so what is our oscillation? Our oscillation I can say is m2 minus m1 sine theta into g by m1 plus m2. Okay, so this is how we got our, you can say, oscillation. Let's try to find out the tension. Now tension, I can use any of the equation and I can substitute over here. So I can say tension is equal to, I will use the first one, I will say m1a plus m1g sine theta. Okay, so if I go on with this, this is m1 into m2 minus m1 sine theta into g by m1 plus m2, okay, plus m1 g sine theta, that what it is. So if I go on further solving it, I will get t is equal to, if I cross multiply, what I am going to get, I will get m1 m2 g, okay, minus m1 square sine theta into g, plus you can say m1 m2 g sine theta plus m2 m1, sorry, this is going to be m1 square. Okay, so let's correct this one. Say this will be, you can say m1 square g, m1 square g sine theta plus m2 m1 g sine theta upon m1 plus m2. Now let's see if we can cancel off some term. I think this is gone over here, so that what is left. So I can say my tension in the string is nothing but it is going to be m1 m2, that is common, g, that is common, and 1 plus sine theta upon m1 plus m2, that what it is. Okay, now let's try to go with our next example. So this is how we have found the tension and this is the oscillation given over here. Now let's try to solve over this sort of system, where if I see that this is going to be the tension in the string, this is going to be the tension, and let's, for a moment, let's assume, say this is mass m1, this is mass m2. Now you see that this is m2g acting over here, so this is going to be angle beta, so it is going to be, this component is going to be, you can say m2g sine beta, and if I draw for the same, it is going to be m1g, and this is going to be, you can say, yeah, so this component is m1g cos theta basically, and this component, or the parallel component, I will say, is m1g sine theta, sine alpha over here. So sine alpha here, that what is the angle we have. Okay, now if we see that the entire system is in oscillation of a, okay, so then what is going to happen over here? So if I use like for the block m1, then what I see over here is, you can say t minus m1g sine alpha, this is equal to m1 alpha. This is our first equation. Sorry, this is m1a, oscillation a. Okay, so let's be clear over it. This is not alpha, the alpha is the angle over here, oscillation is a over here, that what it is. Now let's try to do it for the second block, and the second block is the block is moving this way, and so it will have oscillation over this side a. So what I can say over for this is, you can say m2g sine beta minus t. Okay, so this is equal to nothing but m2a, that is our second equation we have got over here, right? So again, if we add it up, what we see is, you can say g is common over here, and what we'll get, m2 sine beta minus m1 sine alpha, this is equal to m1 plus m2 into a. Okay, that what it is. So I can say a is equal to m2 sine beta minus m1 sine alpha into g divided by m1 plus m2. This is the oscillation component we have got. So the oscillation of the block is, or the blocks is, m2 sine beta minus m1 sine alpha upon m1 m2 into g. Now let's try to find out the tension. To find the tension, let's use the first equation. I say T is equal to m1 a. A is what? It is m2 sine beta minus m1 sine alpha upon m1 plus m2. That what it is, into g. Okay, so that what is, you can say m1 sine alpha. Okay, m1 into a plus m1 g sine alpha. Okay, so let's try to solve it. And what we find out here is, you can say it is m1 m2 sine beta minus m1 square sine alpha, so sine alpha, and into g is over here also, plus, now this is cross multiplication, so what we say is m1 square g sine alpha plus m1 m2, and it is going to be, you can say m1 m2, it is g sine alpha divided by, you can say m1 plus m2. Now you see, okay, so what we can do is we will cancel this off. Okay, and okay, so we have left with that simple term, right? And so what is that? So we say that tension is equal to m1 m2 g sine beta plus sine alpha upon m1 plus m2, right? So this is how we can find the tension in such a sort of system, by drawing free body diagram and then solving them. Now let's try to look at our final example which we have got over here. This example is slightly different. Here we like to consider, uh, say if suppose this pulley which is connected, say this is with the mass m1 and this is mass m2, and suppose it is moving in, you can say this is the side direction a, and this is the, say, tension T over here, this is T. Now if you see that if this pulley has got some mass and some radius, if these are things are significant, then these tensions are going to be different. So for a moment let's consider that this is tension T2 and this is tension T1. Now let's try to solve such a problem. In such an example, what you can say that if this is moving with oscillation A, this will be also moving with an oscillation of A, and then there is G acting over here. Okay, G will be acting over here. Now let's try to write an equation for them. For the block M1, if I were to write the equation, I can say T1 minus M1G is equal to M1A. This is my first equation. Now if I want to write for the block 2, now in the block 2, what happens is that this is the tension which is T2 which is acting opposite, and then the oscillation is over here. So what I am going to say is M2A, this is going to be, you can say M2G minus T2. Now you see we have got tension, two different tensions over here, so the two equations are not sufficient for us. So we have to look for the solutions where we will be requiring we should be having more known information to us. So in that case, what will happen is that since this pulley has got a mass and it has got a radius, it will have something what we call as the torque. So we will bring torque into picture, and what we just say is, suppose this is a, you can say the pulley, and it has got, you can say this is the T1 is the tension over here, and say this is the T2 is the, you can say, which is over here, you can say this is away from the body, so the direction here will be this side, and this is the radius r, and this is the mass m. So what I can say, T1 minus T2 into r, this is the torque. Okay, and this torque is what? I alpha. I is what for a you can say the pulley which is circular pulley, it is going to be half mr square, and then there is I alpha, that is the angular oscillation, so that is nothing, it is going to be, you can say, a by r. Okay, so that is the relationship we have. Now you can say that T1 minus T2, it is nothing but, you can say this is a by it is you can say m a by 2. Okay, so we got now our third equation. Now we have got enough equations to solve. Okay, let's try to do it. Okay, so what we can say is this is T1, if I add them up. Okay, so if I add them up, what I'm going to get, I will get you can say T1 minus T2. Okay, so T1 minus T2, that what it is. So this is equal to, you can say that what you can say, this is in the clockwise. So this is T1 minus T2 is equal to R. Okay, tension T. Okay, here one small error has happened. Let's try to correct it. See, what will happen is that this is going to be T2 minus T1 because the motion of, we have assumed the motion of that you can say pulley is over this side. So it is T2 minus T1 basically. So it's T2 minus T1, that what it is. So T2 minus T1 is MA by 2. Okay, now if I see this, if I add these two equation, I will get T1 minus T2 minus plus M2G minus M1G is equal to M1 plus M2 into A. Okay. Now if I try to put this, you can say this is minus MA by 2 plus M2 minus M1 into G is equal to M1 plus M2 into A. So what you say is M2 minus M1 into G is equal to, you can say, this is M1 plus M2 plus M by 2 into A. That what it is. So okay, so we got the equation for acceleration over here. So acceleration is going to be, you can say, it is M2 minus M1, that what it is, and then G divided by M1 plus M2 plus M by 2. Okay, so this is the equation of the acceleration. Let's try to now find out the tension. So for tension we can use, say we have got two sort of tensions, we'll try to find out that. So to find this, what I am going to say that T1 is equal to M1 into this M2 minus M1 into G M1 plus M2 plus M by 2. Okay, so this is M1 into A plus M1G. Okay, that what it is. Now if I, let's try to solve this one and see what happens. Say T1 is equal to, you can say, M1, uh, let's try to say what we can say T1. So this is M1G. Okay, so T1 is equal to, you can say, M1 M2G minus M1 square G plus M1 square G plus M1 M2G, all right, plus M1G M by 2 divided by, we can say it is M1 plus M2 plus M by 2, right? So that what it is. So you can say tension T1 is equal to, so something we can cancel it off here. Yes, this is gone. So what is left is 2 times, you can say, M1 M2G. Okay, and then this is 2 times, and then it is M1G M by 2, capital M by 2, that is the mass of the pulley, divided by M1 plus M2 plus M by 2. Okay, okay, so this is T1 is equal to, you can say, this is what we can take it, M1G will take out common, and we will say this is 2 times M2 plus M by 2 upon M1 plus M2 plus M by 2. This is the tension in the string, you can say first portion of the string. Now let's try to find out the tension in the second portion of the string. We have the equation for that, T2 minus T1 is equal to M A by 2. Okay, better is that I will use second one. Okay, because this is again I have to substitute a lot of values. So I will use, I can say, this equation, T2 minus T1 is this. Okay, let me try to use this one. This will be simple for me. Okay, if I use this equation, then what I'm going to get over here is, I can say T2 is equal to M2G minus M2A, and A what we have got, we have got is, you can say, M2 minus M1G, and this is M1 plus M2 plus M by 2, right? So that what it is. Now let's try to solve for the tension 2. It will become M2 M1G plus M2 square G plus M2 M by 2G, okay, minus M2 square plus M1 M2 G, and here G also, and then what we have here is m1 plus m2 plus m by 2. Then t2 is equal to, you can say something we are cancelling, yes, this we are able to cancel. Now what we get over here, okay, 2 times m1 m2 g, that what we'll get, plus m2 m upon g upon m1 plus m2 plus m by 2. Okay, so here we can solve it off. And I say that my tension T2 is nothing but, I can say, I can take out m2g common, and I say this is 2m1 plus m by 2, it is over here. I think we have missed that one. Yeah, m by 2. Then it is going to be m1 plus m2 plus m by 2. All right. So this is how we can find the tension like in the system which we have got the torque into it. Okay, where the mass of the pulley basically and the radius of the pulley is significant. So this how we evaluate. So we'll look for more examples. Let's see it further. Thank you very much for this video.